today, chemistry. I'm going to have it in the topic oxidation numbers. Oxidation numbers. We're going to be talking what is oxidation, how do you know the oxidation number of an element, how do you identify the oxidation number of elements. So I'm going to teach you today about oxidation numbers. So I want you to listen and also be attentive so that at the end we'll get what our desired result. What is oxidation number? Oxidation number is the number of electron an atom gains or loses during a chemical bond. Come again. I say oxidation number is the number of electron an atom gains or loses during a chemical during chemical bonding. So whenever there is a chemical bonding, an atom an electron must be gained or lost. Why is that happening? Because in every reaction, what every atom is trying to get is trying to do is to obtain its octet structure. To obtain its octet structure or duplet structure. Why they are trying to obtain this structure? So that they can become stable. So every reaction is because of instability in the atoms, and actually every reaction is just to make them that they become stable. So what do I mean by that? Like for example, we start with these elements, but I want to tell you something about oxidation numbers. Oxidation numbers actually is also the number of unpaired valence electron in the atomic shell of an electron. That's a simplest way to find an oxidation. For example, there is an element we call oxygen. The atomic number of oxygen is 8. I know if you don't know how to find atomic number, actually you can actually visit my lesson how I talked about atomic number and element. So it's actually 8. So for us to find the oxidation number of this element, oxygen here, how do we do it? We actually look at the number of unpaired valence electron at the atomic shell. How do we find that? Let's use, for example, the shells. But the first shell, which is the KLM shells, the first shell always contain 2 electrons, and the second one will always contain 8. This is 2, 3, 4, 5, 6, 7, 8. So you look at how many electrons are unpaired. You discover that this and this are unpaired electron. So we call it that this becomes the oxidation number of this element, which is minus 2. Minus 2. So what do I do minus 2? Ask me, why am I writing minus, and is there anyone that is plus? Yes, I want to tell you something. Metals have oxidation numbers that are plus. Most metals has a plus as their oxidation number, and most non-metals have minus. Though some of them there are some that has plus. But why do metals actually have plus and non-metals actually have minus? You discover that metals tends to lose electrons in order to in chemical bonding, while non-metals used to accept electron in chemical bonding. So that's why we have that non-metals, because they will gain, because here now oxygen needs 2 electrons in order to become balanced. So with these 2 electrons it gains, we actually increase its electron by by 2. Remember, the proton is still the same, but the electron increases by by 2. The electron increases by by 2. So that is why it will now become negatively charged. That's why we say that the oxidation number of oxygen here will be minus 2. So I want to also give you a tips. Like for this, if I ask you chlorine, this is chlorine as an atom, and I want to tell you something. Oxidation number of elements in their free state or ground state is always equal to 0. I repeat myself. Oxidation number of elements in their free state or in their ground state is equal to 0. Whenever they are free, they are not combined with any element. They are standing alone. Their oxidation number is equal to 0. So the oxidation number of this chlorine you are seeing here is equal to 0. Likewise, oxygen, when it's standing alone like this, is equal to 0, because why? They are in their ground state. So they only have oxidation number whenever they are trying to combine, or whenever they are existing as an ion. What is an ion? I've said it before. An ion is a charged atom. Is a charged atom. So for example, if you have oxygen being represented like this, this one oxygen is an ion. So the oxidation number here is actually this superscript here, which is with minus 2. The oxidation number of oxygen here is minus 2. So that's actually how we get to know oxidation numbers of of elements. But I want to give you some exceptions. There are some exceptions in this oxidation number. Like hydrogen. Hydrogen will always have the oxidation number of what? +1. Whenever it comes to halide, hydrogen has the oxidation number of what? -1. When it becomes a halide, when it like hydrogen halide, like sodium halide, it will be what? -1. And when you combine with elements that are more what, electrovalent than it becomes -1. Then also chlorine. Chlorine also exhibits this kind of thing. It has variable oxidation number whenever it is in chloric 1 acid. Chloric 1 acid. Chloric 1 acid. For example, let's see the symbol. Chloric 1 acid is written like this. This is chloric 1 acid. The oxidation number of chlorine here is what? Is +1. We know the one I told you before is always what? -1. But the oxidation number here, exception, is always what? +1. That's what. How do you find the +1? How do you find the oxidation number of chlorine here? The number of oxygen, which we have done before, is what? -2. I've told you about that one. The number of hydrogen is always what? +1, except what? In halides. Remember what I've said. So how do we now find the oxidation number of this one, which is what? Chlorine. So how do we find it? If you look at this, this is -1. So this is +1. We say 1 times 1 plus this plus the number. This is -2. So 1 times -2 is always equal to what? 0. Because every chemical reaction will always be equated to what? To 0. So that is it. So if you do 1 times 1 is what? 1 plus Cl plus 2 times -1 will give you what? -2. So this time minus times plus will give you what? -2 is equal to what? 0. Are you seeing it? So we make this the subject of the formula. So Cl is equal to what? +2 -1. This is how we do it. This gets to this. Whenever minus crosses sign of equality, it becomes what? Plus. So Cl becomes equal to what? 1, which is actually what? +1. So you discover how we will now get that the oxidation number of this chlorine becomes what? -1. Are you discovering? So there's also other elements that have variable oxidation number, like sulfur. Remember what I told you about how you get it through shells? Like if we say sulfur, let's use this. We call this tetraoxosulfate 6 acid. Tetraoxosulfate 6 what? Acid. So here now you can see how you find the oxidation number of this sulfur here. Because there are, even when you are giving that, you see when I say sulfate 6 acid. You know, that 6 I said is actually the oxidation number. But how do you find that 6 from here? As when it's written like this, let me tell you, the only way to find it is you already know this, which is 1. You already know this, which is what? -2. So use them, equate them to equal to what? 0. So if I do this, H2, which is H which is equal to 1, that means 1 times 2 plus X plus -2 times by 4. You know why I use the -2 times by 4? Because oxygen has what? The oxidation number of what? -2. So we come here, this times this will give us what? 2 plus X plus this times this will give us -8. Let's use bracket, is equal to what? 0. So here we actually make X the subject of the formula. X is equal to 8 crossing -8 crossing sign of equality becomes what? 8. This is minus. When it crosses sign of equality, it becomes what? Plus. So this becomes plus. So when this plus crosses sign of equality becomes what? -2. It gives us what? 6. That's why we call it what? Tetraoxosulfate 6 what? Acid. So I'm going to also tell you other ones we are going to do, other tips on how to find the oxidation number of elements. Elements in group 1 always have what? Their oxidation number as what? +1. Most of them. Elements in group 2 always have their oxidation number as what? +1. To like elements in group 17, they always have what? -1. So I want to tell you, as far as you know their atomic number of any element, you can actually find its what? Oxidation what? Number by using the what? The number of unpaired electron in their what? Outermost what? Shell. In their outermost what? Shell. The number of unpaired electron in their outermost shell becomes their what? Oxidation number. Or maybe probably their superscripts. The power they are raised to, it becomes their what? Their oxidation number. Like for example, when I taught you about radicals, you can actually go to the videos and see that radicals. When I taught you about radicals, I said that radical about this. You see, this is the oxidation number of this radical. This is the oxidation number of what? Of this what radical. Like this also. The oxidation number of this is -1. The oxidation number of this is equal to -1. The oxidation number of this is equal to minus what? 2. You discover that this their power becomes their what? Oxidation what? Number. This their power becomes their what? Oxidation what? Number. Let me just give you maybe a simple element you may actually know. Let's do what? Cash will be represented with what? Ca. Remember, whenever you're writing this thing, you have to write the first one in capital letter, while this is in small letter. Cash is actually the 20th element. The 20th what? It has the atomic number. So the atomic number of 20. It has the atomic number of what? 20. So how do you actually do that? What we're going to do now is actually, how do we find the what? The valency, or sorry, the oxidation number of this calcium. Remember, I told you that oxidation number is the number of electron that is gained or what that is lost during a chemical what? Bond. So how many did you lose or how many did you gain during a chemical bond? Remember, I told you metals have plus as their oxidation number, while non-metals have what? Minus. So here we do something. This is 20. So representing it in form of what we call KLMN shells. Using these shells, you call it a KLMN shell. And highest for the first shell has the highest of what? We use this as the yardstick. Tell this that this is actually the formula for finding this, how many shells that will be here. So look at this, 2n squared. So you look at this, that we now do 2. This is the one, the first shell, which is here, raised to power 2. 1 raised to power 2 is equal to 1. So 2 times 1 is equal to what? 2. So that's why in here, the highest number of electrons that can be here is what? 2, the first shell. The second one, if you still do it to the second one, it becomes 2 raised to power 2. 2 raised to power 2 is what? 2 raised to power 2 is 4. 4 times 2 is 8. So this becomes equal to what? 8. So in terms of L will contain what? 8 as its what? Highest what? Electron. That's how you continue doing this until you get to the what? To the end. So what am I trying to say? Remember, I'm dealing with this element called what? Calcium. Calcium 20. So if I want to represent it in terms of the shell, remember what I've told you. Make this is the first one. And remember, the rule says, well, you fill it single before you what? You add double. So you don't start filling it this way, this, no. You fill 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You go 11, 12, 13, 14, 15, 16, 17, 18. You have this 19 and 20. And the number of unpaired electrons is what? Only what? 2. So it's easier for calcium to lose these 2 than to gain what? More 6. So here we say that what? Calcium here, if it's like it's written like this, whenever it's an ion, so whenever it's reacting to real like this, that means that the what? That the oxidation number will be what? 2 plus what? 2. I hope that this actually helps you in knowing what is oxidation numbers. In the next topic, I'm going to teach you about valency. It's just similar to oxidation number. And thank you so much.